Okay friends, welcome back. So we'll be now discussing the second video of the electricity. I hope you have already seen the first video. If not, please go and watch the first video because I have given certain very important clues to solve sums in the first video. So now in the second video, it's a continuation of the first video where I'll be discussing some very good important sums regarding the JE sums, regarding JE electricity part of the JE. So let's first start from here. So this is a conductor given whose radius is A and it's varying, and here the radius is B. Its resistivity is rho and its length is H. Question what they're asking is, what is the resistance of this conductor? So first of all, see how to do this sum. So let's choose a distance x, at a distance x, let's choose a thickness dx of the elemental section of the conductor. Okay, so what is the resistance of, so suppose this is R and this is R plus dr because this is a little bit more. So what is the resistance of this length? Dr will be rho dx by pi r square. See, we know resistance is rho L by R. So L here is dx and A is pi r square. Correct? So in the figure, see tan theta, tan the theta, this is what? B minus A, this is B and this is A, so this is B minus A. So I can write tan theta is B minus A, B the perpendicular by the base, so base is H. Also I can write tan theta will be dr by dx. So from here we can find out dr will be H by B minus A into dx. This is dr. So the resistance will now become rho. In place of dx we can put H by pi B minus A and dx by, so here it will be, we have to separate that dx from here. Okay, so dx, sorry, here dx will be, this is dr, H by B minus A, this is dr, sorry, so please make the corrections. So it will be dr by r square. Okay, so the total resistance will be an integration of this from A to B, rho H by pi B minus A dr by r square, where I see that rho H by pi B minus A is a constant and it is dr by r square. So integration of this will be rho H by pi B minus A to, this will be A to B minus 1 by R. So I hope you know the integration. Please, first of all, you should know these rules. Rho H by pi B minus A, so it will be 1 by A minus 1 by B. First you have to put B, then minus, so it will become plus B. So simplifying this, we will get rho H by pi AB, because B minus A will cut. So this is the solution of this section. So this is how we find the resistance of such a varying conductor. It's a very good sum. So you can have a look into that at least 2-3 times before you start doing it. So watch it very carefully. So this is a very nice sum where you can definitely, these type of sums are expected in your exams. So please go through the sums. Okay. So let's move on to the next sum. I would suggest please watch the videos time and again, because only looking once will not help you. So you have to watch the sums. Okay. So let's see one more very interesting sum, that is, there is a square here of equal resistance on all sides. So there's a square here and then this is again there, and also, so all the values are R. So these type of sums you cannot do by series and parallel combination. There is no chance you will be able to do it. So they are asking what is the resistance across A and B. So it's impossible to do without by using just the series and the parallel combination. So watch the trick how to do. In the first video already I gave you a clue. That is, whenever these type of figures are given, then you always have to look for a line which is symmetrically dividing the figure. So I hope, this is becoming a little bit up down, I hope this is the line which is dividing the figure symmetrically into two equal halves. So what is the advantage of this line? All the points lying on this symmetrical line will have the same potential. Remember, all points on this line will have the same potential difference. So if all these points are having same potential difference, that means there is no use of connecting these 2 points. There is no use of connecting these 2 points. So we can always disconnect these 2 points. We can disconnect these 2 points, and because there is no use of joining those 2 points, as current will never flow through those points. So now the circuit becomes very simple. So this is 2R, this is 2R. So these 2R and 2R are in parallel. So 1 by 2R plus 1 by 2R is 2 by 2R, which is 1 by R. And if I reverse it, I will get R. That means instead of this is R. Similarly, instead of this, it is also R. So let us rub this part and make the circuit little bit simpler. So this part is R, and this is also R. That means here, in place of this, I can put that this is an R. So this is R. Similarly, here also was a circuit, and this is R. Clear? So this is R and this is R. So here was a part which gave me R, and here was a part which gave me R. Now the circuit looks like this. So these 3 are in series and these 3 are in series. So I can write RAB will be 1, this will be 3R, 1 by 3R plus 1 by 3R. So it's 2 by 3R. So RAB will be 3R by 2 ohms. So this is the equivalent resistance between A and B. So this is how we solve the sums. So that is the end of this video. I hope in the 2 videos which I have shown some very good sums. So please watch the videos again. And in this also I showed you 2 very, very important, very, very tricky type of sums where you cannot directly apply the series and the parallel concept. You have to have some other type of concept so that you can apply. The concept was the drawing the symmetrical line. Okay. So hope you have got a little bit benefit out of that. So few more very important chapters of class 12 physics will be coming up as when I get the time. So, and I am also uploading the maths classes of physics of the class 12 and class 11. So those who are in 12, those who are in class 11, please keep following my videos, because I'll be uploading each and every part of the class 11 and class 12, especially class 12 students for the maths and for the physics sections. Okay, so keep following my video. Please subscribe my channel, press the bell icon so that it can be shared to many, and you please share the videos with your friends. Okay, so thank you very much.